So now let's get into another really powerful tool, message queues, which are actually pretty simple, at least conceptually. The main idea is that if we have a large amount of application events, and those application events are going fast, so much so that maybe our application can't handle them all at once, and we want to process these events asynchronously. Now, of course, we could scale up our servers, but if we really don't need to do these all at the same time, all at once, it's better to queue these events and handle them at some later time. And that's exactly what message queues can provide for us. So what will happen is those events will be sent to another component called our message queue. And then from that message queue, those events will then go to our application server. And then finally, our server will actually process those events. Let's take payments, for example. Payments maybe take a long time to process on our server. Maybe we have to do some analytics data on them. And then after we've done that, after we've processed the payment, then we write something to our database. We write that transaction or something like that. So this is a pretty basic scenario of using a message queue. The main thing to notice is that we've decoupled the events, and this could actually be its own application. Like this could be its own server creating some events, some user events like gaming data or something like that. And then those events go to some queue, which is durable actually. All the stuff that's stored, those messages, those events, when they're stored in this queue, they are durable. They are persistent. If the queue crashes, that data will still remain there. It's not lost. It's not being stored in RAM. It's usually being stored on disk. So we have decoupled these two services, the one that will produce the events and the one that will actually receive and process those events. These are decoupled, and this queue architecture will allow us to process the events asynchronously and allow us to handle a larger amount of scale, because those events don't need to be processed instantly. We can queue them until we're able to process them. And with this type of example, we'd probably process them first in, first out, but there are other methods we could use. Now, at a high level, this is really all there is to message queuing when it comes to system design interviews. We can decouple our services, process events asynchronously, and handle a larger amount of scale. But there's a few more features and topics I'm going to be talking about, especially when it comes to pub sub, which is a popular variation of message queuing. So first of all, there's actually other helpful features that message queues provide. I already talked about how they are durable. So in some ways, they are actually similar to databases, but also the way data is transported between the queue and the destination can vary. It can either be polling, where the server is actually polling from the queue. It's periodically checking, does the queue have anything new, any new messages? If it does, I'm going to take some of them. If not, I'm just going to try again, maybe in a few minutes. We can also push messages directly from the queue to the server whenever we get them on demand. And on top of that, in some cases, the application server, if we're pushing data, may not be able to process the data immediately, or maybe it may have missed the message or something may have gone wrong. So there's actually a way for the server to tell the queue it can acknowledge that it received a particular message. It can act that message. And after that's done, the queue will know that this particular message that I was trying to send has been received and processed by the server. So I don't need to send that message anymore. If the queue sent that message and it did not receive an acknowledgement from the server, if it didn't receive that, then the queue would try again. It would keep trying to send the message a certain number of times or until the server acknowledged that it received the message and processed it. So this is a sort of way where we do not lose messages. We don't send messages to the server that it can't process, and then those messages just get dropped. We never see them again. We do not want that to happen. So there's a lot of features like this that are built into queues to make them durable, to make them reliable, and to add this functionality to them. And so far, we've mainly talked about one-to-one. There's going to be one application going to a queue, and then that application is going to feed into another one. But it actually doesn't necessarily need to be like this. There could be multiple applications feeding into the queue, and there could be multiple applications receiving from the queue. And this brings us to PubSub, where we get these sort of many-to-many relationships. So first of all, PubSub stands for publisher subscriber. And so in this case, the app event producers would be the publishers and the event receivers will be the subscribers. So with this model of message queues, we have publishers that produce events, but these events will go to some middle layer. And this is where we get into this message queue. This is part of our message queue. We will get topics, and these topics will be the ones that receive and store those messages persistently. And these topics will feed into subscriptions. And there could be multiple subscriptions that a single topic is feeding into. And the purpose behind this is that multiple applications can receive from the same topic. So a single topic may receive, let's say, all payment data, right? This topic will receive all payments information, and maybe another topic down here will be the one that receives all analytics information. And maybe this analytics topic will feed into a single subscription. Now, maybe we have just a single app server that we need to receive all of the analytics events. And then from those analytics events, we write it to some logs database or something like that. But for this payments information, we actually need two services to receive from them. One service is going to process that payment, and then another service is going to do something with it, maybe back it up to a database or back it up to some data warehouse. But what I'm getting at is the entire point of having topics and subscriptions is that from topics will basically receive data, and they're a way for us to segregate data. Maybe we want half our data to go to this topic, and then the other half of data is completely unrelated, so we want it to go to another topic. It's sort of like having multiple message queues, and we break them down into what topic of data does this topic need, as the name implies. And subscriptions are essentially a way for us to fan out these topics. Maybe it's not just a single application that needs this topic of message, but maybe we need multiple applications, so we fan it out to multiple subscriptions, and then that's where our application logic comes in. It will receive messages from this subscription, and a single application could receive from multiple subscriptions if we wanted to. The whole idea is that we have all this logic in the message queue so that we decouple our application. Our application is pretty simple. We can mix and match. We get rid of this server. We don't have to change our entire architecture. That's the benefit. We can drop in a completely different API over here that will receive these messages. So that's the big picture here. Message queues can actually come in all shapes and sizes. Some really popular open source ones include RabbitMQ, and nowadays what's even more popular is Kafka. Super popular and super powerful, and this was actually developed relatively recently. A popular cloud-based one for Google Cloud is called PubSub, actually just PubSub. And there are definitely some differences between these, but overall they provide this kind of basic message queuing functionality with some caveats between them. There are trade-offs between them, but in terms of system design interviews, message queues are pretty powerful and pretty simple for the use case that we use them when it comes to just designing these systems.